6 or 7, maybe? Hello, Gerda. Ooh. My dude, JTS, how are you? Let's, let me go ahead and put this up here. Make sure we're running the right way. Okay, we are. All right. Nice. Nice, nice, nice. All right. I'm a little hungry today. Okay. How is everybody today? How is everybody doing today? Hopefully you're doing really, really well. Okay, no more chips. Tired? Oh no. Anna. Anna just chilling out today? Alright. Okay. Good, good. Positive progress. Okay, change your grade to a B. Anna's a little tired. That's okay. Hopefully this will inject a tad bit of energy. I can't promise much considering it's mathematics, but you know. Hi, Jace. Oh no, stomach bug. Oh, don't remind me. Stomach bugs are no bueno. My weekend was very good, Chase. Very good, very good. I didn't get as much done as I wanted to, but you know what? I was still productive nonetheless. So I'm pretty happy about that. How about your weekend there, Chase? Oh. Congratulations. Okay. You slept all day Sunday. Oh, well. If you slept all day, then I'll say congratulations to you. You did better than I did. Go grab the book here from behind me. Hang on a second. See, it's a Tuesday. We're all chilling. All right, having a great time. All right, that's very good. Don't forget. Um, remember, it is 1 week before Election Day, so please go out and vote if you have not done so already. Again, please go out and vote, and make your choice be heard. So there's a lot of people early voting right now. A lot. It's close to 70 million people have early voted already, which is an all-time record, which is quite amazing, actually. Yeah, I'm gonna give you a speech about who to vote for. No, please, no. You should decide that for yourselves for your own reasons. You have info on your emails? Are you talking about why you don't receive them from me? Because I receive them. True. What's going on with the emails there? Is there? Oh, all right. If it's the class's emails, I'm like, okay, what did I do, bruh? Okay. If you have some details for me regarding that, then okay, no problem, Chase. All right, man, need to eat and everything. All right. Okay, I think we are good to go here. Okay, so let's go ahead and let's do this thing. Let's see. Oh, that's that. Okay, that's not a problem then. Yeah, I don't care about that. Okay. Yeah. All right. Well, I mean, if that's your preference, so be it. I just don't tell people who to vote for. Everybody want to vote for whoever. I said okay. So you have your hat, and I have my hat. You vote for who you want. I'll vote for who I want. All right. Everybody gets a voice. So this channel here is very politically neutral. All right. I will not criticize you for your choices, irrespective of that. But at the same time, I just ask for everybody to be respectful. So, about that. Everybody has a point of view to come from. So, I have friends who are on both sides of the aisle. So, I respect both their points of view. And it helps me understand those points of view a lot better. Uh, all right. All right, let's get going here. Okay, let's get started today. Welcome back to Tuesday. Hopefully, you have a nice weekend. So, today, all right, today, now, you guys can give me a little reminder here about last time on Thursday. Now, I know I assigned a test there last time, right? And I had it due the following, I think, was it Wednesday? Something like that? I think so. You guys give me a reminder that there's so much been going on the weekend that literally I have like 15 things floating in my head. So no, it's not due tomorrow. No, 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 no. Goodness no. Definitely not, and definitely not happening. When did I have this due? Is the question. Um, I have it due. Let's see. It's not due tomorrow. Yes. Okay. So that is due on Sunday, right? Yes, Sunday. That is correct. Okay. So that is due on Sunday. That is this Sunday here. Um, okay. So sorry, 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 sorry. It was my fault. You can blame me. All right. So it is due on Sunday. All right. All right. Just had to be sure to check on the due dates there. No problem. Good to go. Easy peasy, lemon squeezy. Okay. I yes, I'll do it right now. Okay. All right. You never saw it coming. Okay. You never saw it coming. um. Well, it is Sunday, so it's not too far. It's a little bit. It's not super far away, but just get it done and do your best. That's all I ask for. Simple enough. All right. Now, what I want to ask you guys here really quick is, considering of course there's a is again the test on Sunday there. Do you want me to go over a few of the review problems here? I'm going to have to do at least one section here today, but that shouldn't take us too long. But do you want me to do a few of the review problems? Yes? Okay. All right, let's go ahead and do a few of the practice problems there. And we'll see what we're working with, okay? So let's take a gander. Add a few of these guys. All right. And let me see here if I can. I'm gonna make it a bit bigger so it's a little bit easier to read. So just let me know if it's too big or too small, and then I'll adjust the thing. So just watch me pull an all-nighter on the homework. Okay. Just make sure you have some coffee with you, I guess. All right, let's go through each one here. I think I'll make this slightly a bit smaller. There we go. Okay, so let's go with this first one here. It says we're going to find f of x for each x value in this table. So we have 5 to the x power here. So we're trying to just fill in the table here. So we have 5 to the negative second power. So can anybody tell me what's 5 to the negative second power? What's that going to be? All right, 1/25 is correct, right? So remember that 5 to the minus 2 is 1 over 5 squared. So let's put up our dude paint tool. So remember 5 to the minus 2 is 1 over 5 squared. Again, 1 over 25. Okay. Sadly, I don't think we have time for horse drawing today. All right, how about -1? 5 to the minus 1? 1/5, okay, that's right. All right. Now I'll fill in the others, these two here, 5 and 25. So that's fine. How about 5 to the 0? 5 to the 0 power, what's that? 1. That's correct. Okay, so be sure not to put 0 there. Remember, that's 1. All right, anything to the 0 power is automatically 1. So that's going to be your answer. That's all they're asking for you here in this question, is just filling in the values in this table. Okay. Let's move to the next one. Okay. Okay, this is graphing. Again, plotting 5 points on the graph of a function. So in this particular case, it's a good idea to just go ahead and just map it out as best as you can using a, that's not what I wanted. Let's go back here. You know, just use a simple XY table for this. So again, you have 4 times 4 over 5. If you got a question on the review there, please go ahead and ask, Chase. That's perfectly fine. Anything's okay. Anything's fair game. It's a review, so you know, I don't care which way you want to go. Put 0, you get 4. Let's see what we get here. We get -1. What is that? 5. Okay. -2 is what is that? It's 16. So that's 4. That's 25 over 4. Okay. All right. 1 is 16 over 5. And let's see, what's 2? 2 is a 16 over, so 64 over 25. Okay. All right. All right, so you can find these. You can use the calculator here. I just went ahead and used my brain. So let's go ahead and map these out here. Okay, so oops, it'd be helpful if I have this. So we have some points here. Let's do it. 0, 4, which is, let's map these out here. So we just plop in here. So 0, 4, plot that point. All right, and then we just want to rinse and repeat with the others. So -1, 5, and we plot the point, and then that's the next one here, -2, 25 over 4. Okay, you can plot that point. Next is 1, 16 over 5. Okay, plot that point. And 2, 64 over 25. Okay. All right, then we play connect the dots. Okay. Oop. Oh, and one asymptote. Okay. So they want me to do one asymptote here. So we'll do an asymptote right here. Yeah. Okay. Now we'll plot this thing. There we go. We got our graph, just like so. Okay. Make sure to have an asymptote there as well, and it'll plot those points accordingly. All right. Good stuff. All right. Hopefully there are no questions about that. Okay. Which one would you think would be more challenging? Oh, good question there. How do you know the asymptote is 0? I know that the asymptote is 0 here, Morning, is because of the fact that I'm not adding anything out here. So remember, when we add or subtract on the outside here, that's a vertical shift up or down. So if this was like -1 here on the outside, that would shift the asymptote down by 1. If it's let's say it's +1, I would shift the horizontal asymptote, sorry, up by 1. Yeah. That's how I knew exactly where the asymptote was going to be. And if you look on a calculator, it should net out the same way. All right, let's skip around a bit. All right, let's try 24 here. All right. Solving for logs here. Solving for logs. What do you think about this one, guys? Solving for logs. What do you think we should do first in this problem if we're going to solve for x? Okay, use rule 1 here. Okay, I agree. We're going to multiply those together. So we're going to have log of 5 times x minus 8 equals log of x. Now, in effect, all you have to do is essentially cancel out the logs or just set both the things equal to each other. So we have 5 times x minus 8 equals x. So we have 5x minus 40 equals x. Subtract 5x on both sides. And so here we're going to get minus 40 equals minus 4x. Divide by -4. And so here x is equal to 10. So that's our final answer. X is 10. All right, so that's pretty much how you find that problem from start to finish. Once you use rule 1, you then go ahead and multiply there, set them both equal to each other, do some regular old algebra, and bada bing, bada boom, you got an answer. There it is. All right. Any questions about that one? Again, if you have any questions, I'll certainly answer them. All right, let's pick another number here. You guys, let's see, a number from 3 to 23. Okay, so let's pick a number here between 3 to 23 and 25 to 34. So pick a 13. 13. Okay, it's unlucky. Okay, I got it. All right, 13 it is. All right, let's do 13. I'm going to randomly choose based on what you tell me. All righty. Let's do this one here. All right, log of 6 of 1/6. Log base 6 of 1/6. How do we evaluate that? What's that going to be equal to? Log base 6 of 1/6. What is that going to be? Log base 6 of 1/6. Anybody remember? So log base 6 is not on your calculator. But let's say it was equal to, let's say, y. Okay? That's understandable, no problem. But let's translate it over to an exponential. So let's set this equal to y. Remember how this goes. If we're going to translate it from a logarithmic to an exponential, we want to ask ourselves 6 to the y power, that's the base to the y power, which is out here, equals 1/6. Well, 6 to what power is equal to 1/6? 6 to what power is equal to 1 over 6? -1. That's right. Nice. Okay. So that's exactly what that answer is going to be. If you need help with that one, just go ahead and write it out in exponential form. And that should be just fine. Okay, Chase got a bunch of them. Okay. We'll answer this one, and then I'll do some of the others that you listed there, Chase. How about log base 4 of 64? So we want to set this equal to y, and we're just going to take this base here of 4. We're going to have 4 to the y, okay? Okay, so you got to remember the translation there, Gerda, all right? So the translation is, again, if you have log base b of x equals y, remember that translates to b of the y equals x, okay? This is the translation between logs and exponentials, all right? So that's why it translates to say 4 to the y is equal to 64. Now the question is, what is y equal to here in this case? 3. That's right. Good. All right, and that's our final answer for that is those two. No problem. Are there any questions? Nice job, Planet. Nope, nope indeed. Okay, now Chase had a few here. Let's go to 9, or yeah, let's go to 8 and 9. So those are the others he wanted to do there. So let's do 8. Okay, so let's go over this. It'll be a compound interest problem. So this one here can be slightly a bit difficult. So let's cover this. Let me just try to make this bigger, so I can just shrink this back down. Okay. All right, there we go. That's better. All right. Okay, so let's go ahead and read this off here. So, okay, there we go. All right, so an amount $18,000 is borrowed for 13 years at a 3.75% interest rate, compounded annually. If the loan is paid in full at the end of that period, how much must be paid back? Okay, use the calculator provided and round your answer to the nearest dollar. Okay, so what we need here in this problem is we do need a formula here in order to figure out how much it needs to be paid back at the end of these 13 years. The formula that you'll need here is this one. And we talked about it before, but it's been a while. Maybe that was P times 1 plus R over N, and we take that to the NT power here. Okay, so we have this formula that we need here for number 8 to make it make sense. Now, of course, everything here has a meaning. So again, P here is principal. Okay, R here is the interest rate in decimal. Okay, T is time in years. N is the number of times compounded per year. Okay, and A is the actual amount. So let me actually put this like this. This looks a little awkward. So rewrite N here. Go. Okay, and that's specifically for N. And then A is the ending amount. Okay. So what we're going to do here is we're just going to set this up appropriately. So A here is, we want to figure out how much we're going to pay for this loan. Let's just go ahead and take some numbers here. We have $18,000 that we borrowed, 13 years, 3.75% interest compounded annually. All right. So our P here is going to be, let me get that one more time, 18K. Okay, so 18,000. Multiply that by 1 plus R, which is 0.0375. Again, that's 3.75%. Since we compound annually, then N is going to be 1. This will be 1 times 13. Remember, it depends on the wording. If it says it was compounded monthly, you'd have N is equal to 12, and so on and so forth. So pretty much after this, it's calculator time, and pretty much you have to use the calculator, not given a choice here. Okay, and we're going to figure out what this answer is going to be in this case. Okay. Unless I'm a math god, which I'm not. That's okay. You can use that equation and just write it down and have it as a little reference, okay? On like a cheat sheet or something. That's fine. So here we get $29,048, and looks like we get 11 cents. So our answer here, because we're rounding to the nearest dollar according to the problem, will be $29,048. So 29 0.048 will be our answer to this. Any questions about that? Okay. All right. Now, hang on. Okay. Hanging on. Hanging on. Not doing nothing. It's fine. This problem here, number 9 that you see on the screen, that one will use A equals PE to the RT power. So this problem here, because it says it's compounded continuously. So if it says it's compounded continuously, this one uses exactly as you're saying there, right? Yeah. No problem. Yeah, so there is a distinct difference between the two. That's true. Wait, what the? Meh. Okay. All right, so if we do this one here, let's do this one here. We get A equals PE to the RT power, again, as was correctly stated. Yeah, no problem. That's what I'm here to help you guys with. So if we have to review today, then we review today, as if it helps you on your test. I got plenty of time to spare anyway, so it's really not too big of a deal. We'll be going through a couple sections a day for a while, but hey, it'll be worth it. Okay. Now, our principal here is $3,300. So, because that's what Yoko deposits. We have an interest rate of 3%, so 0.03 will represent 3%. And it looks like 2 years, because we want to figure out how much she'll have in her account after 2 years without making any withdrawals. Okay, now be sure to put this in correctly in your calculator here. So if you need to put an extra set of parentheses here, go right ahead. So I have 3,300 here. E to the 0.03 times 2, close parentheses. And so on your calculator, you should get 3504.06. And it says to round to the nearest cent. So that's what we're going to do. Okay, and that's our answer. Okay, any questions about that before we move forward? I love math. Suddenly, math is magic. All right. Now let me look at your list there, Chase. Okay, 16 and 19 are next. Okay. So let's move to 16 and 19 here. That's fine. Okay. So let's go to number 16 here, and it says to use the properties of logarithms to evaluate each of the following expressions. Okay, so let's see what we got going on here. See if we can figure it out. All right. Okay, so we have log base 6 of 4 plus 2 log base 6 of 3. All right. I can see where we're going with this. All right. So the first thing that we're going to do here in this problem is all we're going to do here is simply, I'm going to shrink this down here for a second. Need about a little more than half that screen. Be good. Okay, so what we're going to do here specifically is we're going to take this 2 and we're going to bring it out here to the outside. Okay, so we want that to use the power rule in this case. So we're going to have log base 6 of 4 plus log base 6 of 3 squared. Now, as we know here, 3 squared is 9, so that's okay. So log base 6 of 4 plus log base 6 of 9. All right. Next, we're going to use the product rule because we're adding 2 logs together. Wow, here they come. All right. Boop. The bands. All right. Yep. Do you want to become famous? No, I don't. Absolutely not. If people brought traffic into this channel, holy crap, it would be insane. Like it would be like, it's like 1,000. Let's say you get like 10,000 people in the channel. Be like, oh my god, what do I do now? I'm like, I'm trying to teach a class 10,000 people later. I'm like, oh my gosh, really? All right, now I gotta multiply here. Yeah, right. That's true. That's true. Then I'll have to hire a ton of mods and TAs and stuff, and be like, yeah, I need the real people to ask me the questions. All right. Although honestly, I'm not too worried about that. So, not too worried that I'll ever get too popular here on Twitch. So, I guess that's not a bad thing. All right. Now here we get log base 6, and we get log base 6 of 4 times 9. So remember, we're multiplying here, 4 times 9, since we can go ahead and use that rule. And so we have log base 6 of 36. Can anybody tell me, what is log base 6 of 36? New feature unlocked. Yeah, what feature would that be? I don't even know. I don't use half the features. So 2. That's correct. 2 is correct. Yes. That's right. 6 to the y is 36. Exactly, Gerda. You got it. That's right. So 6 to the y is 36, right? Biggest class. There you go. Yeah, that's the new Twitch one, the biggest class in the educational channel ever made. Biggest real class ever. Nah. All right. 2. All right. See, we got this. We got this. Okay. All right. Let's look at letter B. Okay, letter B. We got 2 for the first one. Now, what about letter B here? It says we have natural log of e to the 5th minus natural log of e squared, and we want to figure out what that's equal to. Well, that one's actually pretty easy. That one will take you no time at all. Natural log of e to the 5th minus natural log of e squared. I make a point of contention here. I already know the answer to this question. I looked at it for like I looked at it for like 3 seconds and I already knew it. Because the answer is indeed 3. Alright, so I know that for a fact. Why do I know this? Natural log and e effectively cancel each other out. They leave you with the number 5. Okay, Natural log and e leave you with 5. All right, natural log and e here squared leave you with 2. 3. Yes. Remember, natural log of e to the x, remember, I'm just using this idea. Natural log of e to the x is equal to x. Technically, I could divide. You're right, because I technically do have the same logs. Only I'm just going to get right back to where I started again. Because we have like e. So basically, if I divided, which is true, you can. Right? But in effect, you're actually still, subtracting the exponents as you were before. So you're going to end up with like natural log of e to the third, which still equals 3. So you still end up with the same answer, just in a circuitous way. That's all. Okay, so that is number 16. Let's see, 19. 19 was the next one there. So let's look at 19. Okay. Oh, I know you guys love these. These are the best. I know you guys love these. You're like, oh my gosh. I'm like, yeah, that's right. Okay. Yeah, that's fine. That's fine. You asked to review. That's exactly what it's here to do. Okay, so we want to express this as a single logarithm. Okay, and we're going to use those rules that we've been talking about, the product rule, the quotient rule, and the power rule that we've been using in several of these examples so far. So if we take a look here, we have 5 log base m of x, okay, and we got minus half log base m of z, and then we're going to have plus 7 log base m of y, okay. Now the first thing that we're going to do here is we're going to put all these numbers on the outside. We're going to put them as exponents here as part of our variables. So that should be z out there, sorry. Okay, so what I should have here is I'm going to have log base m of x to the 5th minus log base m of z to the 1/2 plus log base m of y to the 7th. So this is what we have here so far, okay? Okay, now let's use our quotient and product rules here. Now we have subtraction right here, so that means we're going to divide. So we're going to divide like this. We're going to have log base m of x to the 5th divided by z to the 1/2. We're going to add log base m of y to the 7th. All right. And then, since we're adding here, we're going to use the product rule. We're going to multiply by y to the 7th. So this is all going to be log base m of x to the 5th, y to the 7th, all over z to the 1/2. Okay, and that is going to be our final answer for this problem. And that's it. Questions about that one? Again, we're just doing the rules there, the same 3 rules. Again, make sure you have those 3 rules kind of written down on a cheat sheet there. That'll be helpful. So 26, 27. Okay. All right. Let's see here. Any questions so far? I hope that makes some sense. Okay, let's do the next one then. All right, I'm going to move on then. Let's do 26. Yeah, you can use a cheat sheet for the test. I would have given one to you if we met face to face. Yeah, go for it. Yeah, cheat sheets are definitely allowed, so. Is it possible to use math logs in real life? Yes, of course. Of course there is use of math logs in real life, such as logarithmic growth versus exponential growth. Some things taper off over a long stretch of time. Think about your height, okay? Like maybe growth, maybe growth of a child up into the age of like 20, maybe 25. Like it's like a logarithmic graph. You gain a lot and then you start tapering off by the time you get 25. Well, maybe not for you. Don't forget. Let's think about logarithmic. Let's see. Where would you use logarithmic graph? Bridges? Bridges use logs. You have to use logs and bridges when it comes to engineering. You don't have much of a choice on that. How do you think bridges look like? It's a logarithmic curve. I mean, you can if you want to. You could use shapes and things. I just think it's more complicated. Medical chem stuff, bio stuff, yep. Absolutely. Let's not forget about, let's see. What's used for logarithms there? Where is that useful for, again, in the med field? Ah, right. How much medicine is contained within your bloodstream depending on body type is a logarithmic function. Because you're trying to maintain that. The person who invented math was a The person who invented math, math has been around for quite a while. Math wasn't really invented. Math's been used in various civilizations for quite a long time. Math is probably the oldest subject amongst any subject, so. If you're talking about data collection as well, data collection is used with logarithmic graphing. So that can certainly be, it can model, for example, a logarithmic function. Yeah, it is. Well, if you're gonna do like if you're gonna do predictive analysis, then predictive analysis is very heavily reliant on, again, modeling of some variety. You take a look at a set of data, you determine whether that set of data it best fits a certain, does it fit a logarithmic data set? Does it fit an exponential data set? Does it fit does it fit a linear data set? And then you can accurately predict based on any one of those models which one actually fits at the end of the day. By the way, am I a math teacher? Yes, yes, I am. Mathematics professor. That hence the name Professor Chibs. Yes, cheat sheets are allowed for this test. Absolutely. Go ahead. Not a problem. Remember, we're all part of we're all trying to learn here. That's the whole point of that's the whole point of this stream. Is to learn and have a little fun along the way. Oh, sure. Yeah, you can certainly ask the Chibs part there. Sure. My actual handle is Chibs is short actually for my actual handle. So my actual handle is actually short for this. We're all in it together when it comes to like doing college stuff for, any subject, especially during tough times. Oh, I can explain that. So chibi means really small in Japanese. Um, and then konbini is all right. So that's what it means. I made it up one day. It was a long time ago when I was living in Japan, actually. I thought it rhymed, so I'm like, okay, cool. That's my handle. That's my screen name, Chibi Konbini. I'm a very tiny, very small convenience store. Yes. I said it rhymed. It sounded just fine, and I just decided to keep it ever since. So, you know, so that's where the Chibs part comes from. My my old guildmates used to call me Chibs just for short. So it's like, yeah, that sticks. So when I made up this channel, I was like, oh, well, I'll just make up Professor Chibs. As I'm like, all right, this works out. Cool. That's a very small convenience store to you, planet. Oh my gosh. Uh, hilarious. Me, I'm a millennial. Me, I'm millennial. No, no, no. Goodness, no. Oh no, I am not a millennial. Not even close. In spirit, though, that's true. But I was born in 1979. That's when I was born. So, what's my favorite video game? Well, right now I'm playing Barely Missed the Cutoff. It's fine. That's fine. I don't mind. It's not a big deal. Um, my opinion on well, I never played The Last of Us 2. I mean, I saw some of the gameplay. It had the same gameplay mechanics, but the story seemed kind of, I don't know, dumb. So yeah, it felt kind of dumb. Uh, my favorite video game. My favorite video game is going to be wow, there's a lot of games I've played before. Um, Currently playing Baldur's Gate 3. So, now my favorite old school game that I would still want to play would probably be Tecmo Football for the NES. That game was super fun. And NHL 94 for the Sega Genesis, if we're talking retro. I would play those things like religiously all the time. And of course, Metal Gear Solid 1. One of my favorite games that I played through. That was an awesome game. Yeah, those are really good games. All right. 26. I gotta do 26. 5 to the x plus 9 equals 8. Ooh, let's do that one. That one looks pretty good. Trust me when I say this, it's a miracle I became a math teacher to begin with. So, there you go. All right, so how do we solve for x here? We want to round our answer to the nearest hundredth. So hundredth being, again, 2 decimal places here. So if we're going to solve for x here, I'm going to go ahead and take the natural log of both sides. That's the first thing that we want to do. Okay. So if we take the natural log of both sides, we can take this x plus 9 and use the power rule and bring it here out to the left. So we're going to have x plus 9 times natural log of 5 equals natural log of 8. All right. Now, let's not forget something here. Natural log of 5 is just some rando number. All right, that's some random decimal number. I don't know what it is off the top of my head because I really don't know at all. But all I need to do is to actually distribute natural log of 5 to both terms inside the parentheses, just like so. So I'm going to have x times natural log of 5 plus 9 natural log of 5 equals natural log of 8. All right. Oh, I forgot to add one more game to that list. Tales of Symphonia. That's another one. Yeah, Tales of Symphonia for the GameCube. Amazing game. Uh, all right. I subtract by 9 natural log of 5. Okay, on both sides. So I have x natural log of 5 equals natural log of 8 minus 9 natural log of 5. And then, finally, I just divide by natural log of 5 on both sides. Again, natural log of 5 is just some random number, but we divide everything by natural log of 5. So on the calculator here, we want to go ahead and put natural log of 8 minus 9 natural log of 5, and all that divided by natural log of 5. Okay, so we're going to get an answer here. Let's go ahead and figure out what that answer is, because I'm not sure. This is pretty much calculadora time. By natural log of 5. Okay, so what you should get here is minus 7.71. So minus 7.71 is what we get here as our answer. Okay. Any questions about this one? Number 26. Okay. If there are no questions for 26, I'm going to move to 27. Now, it's pretty much the same type of question here, but if you'd like me to do it, I can. That's not a problem. Would you like me to do this one as well? I know, Chase, you asked me first, so for this one, so do you want me to do this one? Nah, that's all good, buddy. Yeah? Okay, let's go ahead and do that one then. Let's do it together. That's what review sessions are for, clearing up confusions and stuffs. Okay. Let's go ahead and 6 to the 10x, all right, equals 13 minus x minus 8 power. All right, let's do all that stuff. All right. Again, the first step here is going to be the same first step we did in the last example. We're going to take the natural log of both sides. And again, we're going to bring these exponents out to the left. So again, I'm not going to do anything different here than we did in the last problem. So what we're going to have is we're going to have 10x natural log of 6 equals equals not natural log yet, minus x minus 8 natural log of 13. So that's what we have here. Now, again, our goal here is to get x is equal to some number. But before we get to that here, let's go ahead and see how we can get x by itself and then do the calculator work afterwards. Now, once again here, we're going to distribute this natural log of 13 here to both terms, just like we did the last problem. Again, natural log of 13 is some number here. Now, what I am going to do here specifically is I'm going to rewrite the left-hand side just a slight bit. I'm going to actually put x times 10 natural log of 6. So I'm going to rewrite it like that. I'm just going to switch the x and the 10 there. I'll show you why that's kind of important here in just a second, but I'm going to go ahead and do that here in this case. And then on the right-hand side, I'll have minus x natural log of 13 minus 8 natural log of 13. Okay, so that's what we have here so far. Now, I want to get x by itself, but I have an x on the left-hand side, I have an x on the right-hand side. So I need to have all the x's on one side of the equation. So I'm going to add an x natural log of 13 here to both sides. Again, this is like the same thing as like saying adding 5x to both sides or something to like that. There's no difference in what I'm doing here and what I would do in a regular algebra problem. It looks more messy, but in reality, you're not doing anything different. Okay. So this is what we have here so far. Now comes the critical step. Now, in this case here, the reason why I wrote x here first, okay, why I kind of flipped it around in that previous step from before, is because it's a little bit easier to see that all you need to do here if you want to get x by itself is to factor it out. That's all you need to do. Just factor it out. So we factor out an x, and then everything that x is connected to, we're just going to go ahead and write it in. So 10 natural log of 6 plus natural log of 13, and that equals negative 8 natural log of 13. So it's a lot easier to see that it factors here in this particular case, okay? So that's why I put the x in the front as opposed to being in the middle. So that way I wouldn't miss it. Now I just divide by that big old expression. Okay. Okay, so here we have our final answer here, which we'll put in the calculator, of course, to figure that out. So minus 8 natural log of 13 divided by the expression of 10 natural log of 6 plus natural log of 13. So we're going to go ahead and put that in the calculator. Okay, we're going to get our decimal equivalent answer here, which is what we want here. Okay. Okay, and it does ask us to round to the nearest thousandth. So the nearest thousandth here is going to be 3 decimal places. So it rounds to the nearest thousandth. Please be sure to read this to see what we want it rounded to. So what I got here is minus 1.002. Okay. And that is our final answer for that problem. Are there any questions about that particular problem? Nope. Okay. All right. Gerda says no emphatically. All right. Fine. Okay. No. Okay. Yeah. I know. I was just expressing your rage toward the test on Sunday. I was just kind of, imitating that. Getting ready for charades. That's what I'm getting ready for. Okay. All right. So the next one here is going to be question number yeah, question, which one was it? 32. I think it was, yeah, question 32. So I'm gonna go to question 32 here, and then yeah, let's make this bigger here. Okay. I'm not mad, you're mad. The whole world's mad. Yes. I blame I blame everybody for my misdeeds. All right. Okay. All right, suppose that a number of bacteria in a certain population increases according to a continuous exponential growth model. Okay. Um, a sample of 2,700 bacteria selected from this population reached the size of 3032 bacteria in 3 hours. Find the hourly growth rate parameter. Shots fired indeed. Okay, so this one here has something to do with what we talked about in the last section of chapter 4. Okay, so this is the exponential growth model. So this was let's go go ahead and just write it out here. I'll show you what we're trying to actually find here in this instance. All right. So we're using this formula here. If you remember, we had A is equal to A0 e to the kt power. So this is our growth model here. A is the ending amount. A0 is the initial amount. T is time. Again, time is not in years, just time, whatever that time is. And K is our constant of variation. So this will be our constant. Again, if it grows, your K needs to be bigger than 0. If K is less than 0, then we decay. Okay, now let's take a look here at our question. What we're given here in this case is that we're given that the sample here has 2,700 bacteria. So that's what we start with. After 3 hours, there's 32 bacteria in the let's say the petri dish or whatever. Okay, so what we can take to the bank here is that we're given a value here. A is 32. That's how much we end up with. We started with 2,700. Okay, and our time here is 3 hours. Okay. Now we're going to want to find the percentage here to the nearest hundredth, so 2 decimal places. Okay, so let's go ahead and find our K here by just plugging into the formula here. So we got 3032. We'll actually make this bigger here. So we got 3032 equals 2,700 e to the K times 3. Okay. So what we're going to do next is we're just going to do some algebra here real quick. And that is we're going to divide by 2,700 on both sides. Okay. So this is going to be some random number here. Okay. Whatever this number is, it doesn't matter to me right now. See if it comes out to be a nice number. I don't know if it does, but no. Okay. It's not so nice of a number, so I'm going to leave it alone for now. All right. I know it's reducible and stuff, but yeah, I don't care about that right now. So, okay. Now all we want to do is solve for K. So to solve for K here, we're going to take the natural log of both sides. So we're going to take the natural log of this and the natural log of the right side as well. Again, the reason why we want to do that is that natural log and e will cancel each other out, thus leaving with natural log of 3032 over 2,700 equals 3K. Now we just want to divide by 3 here. And take a look here. We're dividing natural log of this expression by 3. Okay, so you're going to do the natural log of what's in the parentheses there. That's why I put parentheses around it, so you know what you're taking the natural log of. 3K is cursed. 3K is, I guess so. I guess so. All right, and we're going to divide that by 3. Okay, so we get a K value here. Okay. uh, so here we get 0.03866. Okay. Now, I wanted to point out one thing about K here. K here is just a decimal, but we do have to convert that to a percentage for this for the exam here. So since they want it in a percentage here, rounded to the nearest hundredth, then what we need to do is we're going to just move this over 2 decimal places to the right here. So 1, 2. So we actually get 3.866%. Or again, yeah, 3.87% would be our answer here. So that's the growth there in this case. 3.87% would be our final answer for that problem. So let me go ahead and write that in. Okay. And I'll go back to the work here so you can copy that down. There we go. All right. Any questions about that? Nada. Nada, he says. All right. Let's go ahead and do that last one you asked for, Chase, which is the 34. I'll put that one down so that one says it's done. Let's go to 34 here. All right. A specific radioactive substance follows a continuous exponential decay model. Okay, so we're going to use the same formula as we did the last question. It has a half-life of 11 hours. All right. At the start of the experiment, 27.2 grams is present. Okay. Let t be the time in hours since the start of the experiment, and y be the amount of substance at time t. Write a formula relating y to t. Okay, use the exact expressions to fill in the missing parts of the formula. Okay, do not use approximations. Okay, so let's go ahead and take a look here. Now, the first part that we're going to look at here is there's 27.2 grams that are present. Now, we're going to come back to that, but technically, that is half the answer here. So half the answer here is 27.2, should go there since that is the initial amount that we're given here in this problem. However, the part that says the half-life of this particular substance is 11 hours is the much more important part of this particular half of the problem. That is finding the K here in this case. So we're going to use the same exact formula here, A0e to the KT. Again, as long as K is less than 0, then it's a decay formula here. However, we're going to also use the definition here for half-life, so that way we can solve for what K is. So in this case, how do we do that? Well, let's make an assumption here, and we're going to assume that A0 here is equal to, let's say, 10. That means after 11 hours, my amount here should be 5, since a half-life is half of your original mass after a period of time. So T here is going to equal, again, 11 for 11 hours, and we're going to find our K here in this case. So we have 5 is equal to 10, e to the k times 11. Again, we want to divide by 10 here. So here we get 1/2, which equals e to the 11k. What do you think we should do next? How are we going to solve for k? How do we solve for k here? How do we solve for k? By 10? I don't want, well, I've divided by 10 already, so I'm good to go there. I already divided by 10. I divided by 10, I divided by 10 already right here. So 10 is, yeah, natural log. There we go. Natural log. Good. So take natural log here. Got natural log of 1/2. Natural log and e cancel out, leaving us with 11k. So we got 11 here. So we have natural log of a half divided by 11. So let's take natural log of a half first. Again, be sure to only take natural log of a half, not natural log of a half divided by 11. So you don't want that in one expression. Just want to do this two separate guys. Okay. So we are given a k value here. So minus is 0.06301 33801. Okay. Now, if you take a look here, I wrote out the whole thing, okay? I wrote out the entire thing, all right, I wrote out the entire thing, all right, for k. And that's what they're looking for here in this particular problem. They want the whole value for k in that answer, all right? That's what they're looking for. So when they want k, they're saying, okay, use exact expressions to fill in the missing parts of the formula. Do not use approximations. And they're very strict about that, apparently, in this problem. So I'm taking that into account here. Okay, let me move this over here to half a screen. Okay, so let's copy this down again. All right, so I need minus 0.06301333801. And that's going to be my k value in there. Okay. Now all we have to do is use that exact value, and we're going to go ahead and plug in this case, how much will be present in 4 hours. Plug in t is equal to 4 in the first formula there. So that's what we're going to do. So 27.2 e to the previous answer here. Again, times 4. And so if we do that out, our answer for this is round to the nearest tenth, so 21.1 is what we get here for that part there for letter B. All right. Any questions about that? All right. Any questions about those? No? Okay, great. I'm glad it was very helpful for everyone. All I'm happy for is everybody's, they kind of got it, so that's cool. Does anybody else have any more questions from the review that they would like me to do that we have not done so already? Your eyes have been opened? Okay. No. Okay. It looks like it was another all-day review, but I think that should help a lot. You guys can check back at this replay, and then your skin is clear. Oh, my skin here is a little dirty. It's got this big rough. Got this big rough brown patch on it. Oh wait, that's my whole skin. Oh wait, hang on. Sorry, that was wrong. It's no, no, no. I got it clean. I got it clean. I had to scrub it out. Yeah, that worked out. That worked out just fine. Okay. You have to understand. Some days you have sanity, and then there's all the other days. This is true. This is true. I mean, look, like today has been full of epiphanies and very relevant remarks. Like I got asked in my last class, in the morning, what was the meaning of life? And I was like, "Yep, I know the answer to that one." I'm like, "Boo, here you go." The meaning of life is work? No, goodness no. No. No, 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 no. Work is not the meaning of life. If you would make it that way, then that's sad. I'm sad. Is 42? Douglas Adams would agree, but I do not. So, I guess I'll money then. No, 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 not money either. It's not money. So I figured this out in my early 20s, actually. And the answer I came up with for what I think the meaning of life is that the meaning of life is the answer to me was simple, but the implementation of it is extremely difficult. So the meaning of life is the control of your free will. It purely is a choice of your free will. You know, people have different environments, different circumstances, but you still have the choices that you can make in order to change those environments and change those circumstances. Um, hello. I did a little experiment here. I did a little experiment, so I'll do this experiment with you guys as well, who are still in the chat, and you'll see exactly what I'm talking about here. Okay, so oh, I see Chris in the chat. There you go. Chris was here with that. Okay, so let me have you guys did this with my class before, so I'll have it do it with you guys here. So on the front of your screen here, okay. So I want you to wherever you are, sitting down or standing up or whatever, I want you to stick out your right hand. Just stick out your right hand. I'm going to put it up in front of the camera here. I'll back it up a little bit. All right, and I want you to move your finger. Move your index fingers, just like so, right? Okay, move your index finger. Now, I didn't make you move your index finger. You chose to move that index finger for yourself because I asked. That was a choice of your free will. Your free will made you move your finger for yourself because you decided, yeah, okay, he asked nicely or whatever, and then I decided to move it. Now, you can do this consciously or unconsciously. Now, let me ask again. Let's stick out our hand one more time. And let's ask again. All right? Move your index finger. All right? Now, either you moved your index finger with me or you chose not to. And if you chose not to, that's because you made a conscious choice of the will that you imposed upon yourself, which was moving the finger. Decisions in life can be done the same way. Okay? You either can choose or not choose. The choices that you make lead to other choices later on in life. and thus shape, design, shape, and change those things that you decide to do, um, you know, in the future. Yes, there are environmental factors. Yes, there of course there are things that you're born into. Yeah, those things of course are things that you have to certainly adapt to. But the question is that how do you attack those kind of problems? If your environment's not very good, how do you make sure you can get out of that environment or succeed within that environment? There's a lot of different things that you'll learn in along the way. But all of that is just a control of your free will and what you decide to do with it. That to me is the meaning of life. So, I mean, take it for what you will. Everybody may have a different point of view. But that is what I kind of figured out, is that if I can control my choices and I can control my actions, yeah, I have to be accountable for those, but hey, there you go. First of all, it's happenstance if a tornado will kill your descendants. Anything can happen between here and today. All right? Nothing's deterministic, necessarily. You chose to move your finger. Okay. But we're talking about choices that could have been made a long time ago that has led up to today. I don't think about what will happen from now, but maybe, Gerda, maybe someday you move to Europe, you get married or whatever, okay, and you get married, you get whatever, you have kids and stuff. It's like, okay, cool, you got it, all right, and that could change. We're still doing one topic, right? Yeah, we're kind of out of time for that, so I would need more time in which to do that. I guess the questions kind of lent itself to giving more time. Oh well, Gura's like, yeah, I didn't want to do anything new anyway. So yeah, something crazy could happen. You could move to Europe, you could start a whole new life, and then a new branch of family could magically happen. I remember when my sister did one of those ancestry things a long time ago. They found out that my sister's ancestry was from um, like French Polynesia or Micronesia, somewhere around there. And that means that some dude or some woman, they came from that area a long time ago, took a boat somewhere to the Asian main subcontinent, and there you go. You got yourself a winner, or something to that effect. All right. All right. Any more math questions? Let's ask. And that's how it ships. Yes, I totally agree. Absolutely. Guys, got any math questions for me? Um, or you guys think you're good? Nope. All right. If there are no math related questions from anybody, we're going to end off here for today. Next time, though, we are going to go over two sections here, sections 5.1 and 5.4. Okay, we're not doing all of chapter 5 here. We are going to be skipping around a little bit. So it'll be 5.1 and 5.4 is what's going to be on the agenda for next time. Okay. Again, now you have a pretty good idea about what to expect here for the test. Again, I highly recommend that you please do the review problems so that way you are kept up to date in regards to that. Okay. And you should be good to go. All right. See me next Thursday. You mean this Thursday, right? You mean planet? You mean like 2 days from now, right? You gonna scare me here. 2 days from now. I'm gonna see you in 2 days. He's ditching. Oh no! No promises. Yeah, okay. Okay, you have yourself a wonderful evening. All right, everybody have a very wonderful evening. Okay? Take care of yourselves, everybody. Stay safe, stay healthy, and stay sane. All right. Take care, everybody. We'll see you all later. All right. Take care. Bye.